Let's take a look at this example. Okay, so what I was supposed to do first with this circuit. For sure, in order to make this circuit looking a little bit simpler, I would redraw it. Okay, so my way to redraw it is simply label my positive terminal of the power supply by letter A and negative by letter B. Okay, so this is my power supply. Okay, voltage source. Okay, now this is my terminal A and this is my terminal B. Please notice that resistor R1 is connected to terminal A, okay, and terminal B. Okay, so I'm going to draw over here resistor R1. Now let's take a look at resistor R2. R2 is connected to point A, okay, and R2 is connected also to point B. This is my connection over here. So I'm going to draw resistor R2 in parallel with resistor R1. Now let's take a look at resistor R3. Point A, okay, is also connected to resistor R3. See, this is the connection. It's like a conductor over here, right? Piece of wire which connects point A with resistor R3. So this is my R3. Okay, and the other terminal of resistor R3 is connected to point B. Okay, so this is my R3. And let's take a look at the resistor R4. R4 is connected to terminal A. Okay, and other side of the resistor R4 is connected directly to point B. So we can redraw this circuit like this. Okay, now let's see what we're supposed to find. We have to find the current which goes, okay, from this point to this point. So I have to find the current between resistor R1 and R2. So I have to find this current. Okay, other words, this is current I 2, 3, 4, because this current will go through the resistor 2, 3, and 4. Next, I'm supposed to find the current which will go through resistor R4. Okay, so I have to find I4. Okay, I4. So next, I'm supposed to find I total. Okay, this is my I total. Let me remind you that this one is going to be also I total. Okay, so this current which will go through the circuit and the current which will get back to the voltage source is also I total. So what we're supposed to find first? Because we have given voltage source and we have given all resistances, so we can find the current through each resistor. So we have to keep in mind that this is parallel circuit, so V1, which is my voltage source, is equal to VR1. This is also equal to VR2. This is also equal to VR3, and this is also equal to VR4, and this is equal 18 volts. Keep in mind that in parallel circuit the voltage across each resistor is equal to the voltage source. Okay, this is my V1. So now we're supposed to find the current which goes through each resistor. So if R1 is equal VR1 over R1, where VR1 is equal 18 volts over R1, which is equal 1 kilo ohm. Okay, 18 volts divided by 1 kilo ohm is equal 18 milliamps. Next, I'm supposed to find current which goes through resistor R2. R2 is equal VR2 over R2, which is equal 18 volts over R2, which is equal 2.2 kilo ohms. Okay, this is equal 18 divided by 2.2 exponent 3. Okay, let me convert my calculator to engineering notation. Okay, so this is equal 8.18 milliamps. So this is 8.18 milliamps. Next, I'm supposed to find current which goes through resistor R3. So I have IR3 is equal VR3 over R3. Please notice that I always write the formula first, and after that I plug in the values. Okay, this way is going to make you better understand the problem, and in the future, if you were supposed to review the material, you are going to know from where you get what. Very often happens that students simply just write the numbers, and if it comes to the review, they are lost because they don't know from where they get what. Okay, so I recommend you to write always formula first, and after that perform the calculations. So if VR3 is equal 18 volts divided by R3, which is equal 3.3 kilo ohms. Okay, so I have 18 divided by 3.3 exponent 3. This is equal 5.45 milliamps. Okay, so this is IR3. Now we're supposed to find IR4. IR4 is equal VR4 over R4, which is equal 18 volts over 4.7 kilo ohms. This is equal 18 divided by 4.7 exponent 3. This is equal 3.83 milliamps. Okay, so this is the current which goes through the resistor R4. Okay, so we found the currents through each resistor, and now we're supposed to find current I total. We're supposed to find I2, 3, 4. Okay, and we found already I4. Okay, I4 is equal to IR4. This is the same thing. So, okay, I4 is equal to IR4. Okay, so next we are going to find the current I2, 3, 4. It means this is the sum of the currents IR2, IR3, and IR4. Okay, so I'm going to write this like this. I2, 3, 4 is equal I2, or we can say IR2 plus IR3 plus IR4. So this is equal, IR2 is equal 8.18 milliamps plus IR3 5.45 milliamps plus IR4, which is equal 3.83 milliamps. So my I2, 3, 4 is equal, let me use the calculator, so I have 8.18 exponent 3 negative plus 5.45 exponent negative 3, because this is milli, plus 3.83 exponent 3 negative. This is equal 17.46 milliamps. 17.46 18.46 milliamps. Okay, so this is my current which will go through this connection. Okay, so this is the current, which is simply the sum of currents which go through these three resistors. Okay, next we're supposed to find the total resistance. Okay, we're supposed to find total resistance. So total resistance, I total, is equal IR1 plus I2, 3, 4. Simply we're supposed to add the current which goes through resistor R1 plus this current. Okay, this current plus this current will give me I total. This is KCL. So we have IR1 which is equal 18 milliamps plus I234 is equal 17.46 milliamps. Okay, again I'm going to use the calculator just to practice. So I have 18 exponent 3 negative plus 17.46 exponent 3 negative. This is equal 35.46 milliamps. Okay, so this is my I total. Now next I'm going to verify if my answer is correct. Okay, I'm talking right now about checking if the value of I total is going to be equal to the value of I total, which I'm going to find in a little bit different way. So first of all, I'm going to find the total resistance. R total is equal, okay, 1 over, open parenthesis, 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Okay, because I have more than 2 resistors, I have to use this formula. So I have 1 divided by, open parenthesis, so 1 over R1 is 1 kilo ohm, so I have 1 kilo ohm, plus 1 over R2, which is equal to 2.2 kilo ohms. Okay, I have these values given on my diagram. And I have plus 1 divided by R3 is equal 3.3 kilo ohms plus 1 divided by 4.7 kilo ohms. Okay, so R total is equal, I'm going to use the calculator again, 1 divided by, open parenthesis, 1 divided by 1 exponent 3 plus 1 divided by 2.2 exponent 3 plus 1 divided by 3.3 exponent 3 plus 1 divided by 4.7 exponent 3. Close parenthesis. This is equal 507.52 ohms. Okay, so please notice that total resistance is less than the lowest resistance in the circuit. Okay, lowest resistance in the circuit is 1 kilo ohm. We get R total equal 507.52 ohms. So it means that so far we are doing fine. Next, I'm going to find total current. I total is equal voltage source, which is V1, over R total. V1 is equal 18 volts divided by R total, which is equal 507.52 ohms. Okay, so this is equal, and I have 18 divided by 507.52 52. This is equal 35.46 milliamps. 35.46 milliamps. Okay. Please notice that we found I total by adding the currents, okay, by using KCL, okay, and we found that this is 35.46. We found the total current also by finding the total resistance, okay, and dividing voltage source by total resistance. We get the same answer. So it means that all our answers are correct.